Right, guys. So just use a ladder method. Now, some of you are going to choose to not use a ladder method and to carry on with the tree method, which is absolutely fine by me. All right. To be honest, I think I told you yesterday. I've always done the tree method, but when I taught some other students from Russia, they always did a ladder method. That's how they would. Just
What's after for?
use a ladder method for finding the prime factor decomposition. So you remember what the word decomposition means? What does it mean? To break things up. Good. Right. I'm still just chatting over me, Ryan. Now I've done that on video. That's recorded and gone on YouTube. Right in front of me, in the middle of the right in front of me, still talking over me.
Exposed.
Thank you, David.
Because I asked Jason if he needed a pencil.
But he doesn't, because he should come to class for everything. All of it.
Yeah, Jason.
Right, guys. So, using a ladder method, so let's work out, right, the prime factor decomposition of, should we say, 24. So I'm going to put 24 in the top. Can you do the same thing?
Yeah.
All right. Does anyone know how to do this? Austin, maybe. You want to start us off? So we do the same thing as before. Now I've put down here, just to help, the list of the first few prime numbers. So what we do is we go down the list. Does 24 divide by 2? So what I'm going to do this time is, instead of doing the tree, I'm just going to write that here. So I've got a 2. But I'm going to divide the 24 by 2. So 2 times what makes 24? 12. So I'm going to put a 12 in there. I'm now going to look at it and say, right, I'm going to carry on my 2. Does 2 go into 12?
Yeah.
So I'm going to write another 2, and the answer is
6.
6.
Oh, this is.
Does 6 go into 2 go into 6?
Yes.
Okay. And what was out?
3.
3. Okay. What goes into 3? 2? No. 3? Okay, so I'm going to write a 3 and a 1. So as soon as I get the 1, I know I'm done. Okay? So the prime factors then, so you're not going to need to do this bit, but, well, it's up to you. The prime factors will be these numbers here. Right? So if I were to write it out now, it would be 24 is equal to 2 times 2 times 2 times 3. Or if you're into your exponents, right? 2 cubed times 3. But for the greatest common factor, we can carry on. We can leave it expanded like that. How do you feel about that?
That one seems easy. It's yeah, because if you don't have a good grip at this, you'll have to write out that whole thing with the factors.
I mean, I would say this way looks a little bit more structured than like trees can get a bit messy. Should we do another number? Do you reckon you could do? Let's do 54. We'll go for 54. Go for it. You do it. I'll pause the video. People are chatting, therefore I think most people are done. So, first off, does 2 go into it? So 2 and 27. 2 doesn't go into 27, so I'm going to cross the 2 out. Does 3 go into 27? 3 times 9. Does 3 go into 9? So 3 times 3. and 3 obviously then 1. So here's the 1, so it's done. So we've then got this is the prime factor decomposition. So my answer is 54 is equal to 2 times 3 times 3 times 3, or for those of you that are writing with exponents, 2 times 3 cubed. Yeah, what I said, guys, I've given a couple more bigger numbers. Go for it. So this next one, 146. What goes in? 2. Okay. Now, does 2 go into 73?
No.
No. Now here's a tricky one then, isn't it? Because 73, what goes into 73? Well, what we do is we start by, does 3 go into it? No. 5, definitely not. 7? No. 11? What happens when we run out? Carry on. Because we can say 13, I didn't write them, 19, okay, 23, but we're now getting to, if I did, getting a bit too big. So the conclusion we could come to is that 73, the only thing that goes into 73 is 73.
Oh,
So my prime factors are, as kind of unsatisfactory as you might find it, but 146 is just 2 times 73.
so good.
The next one then.
I'm not done.
Well, we're making notes. I'm going to give you a chance to carry on and work on things yourselves. I don't want to wait too long. Okay? 2 times 36. Okay? Does 2 go into 36?
Yeah.
2 times
18.
18. 2 times 9. So my prime factors are 72 equals 2 times 2 times 2 times 3 times 3. Or 2 cubed times
3 squared.
3 squared. Okay. Now that is how we do our prime factor decomposition. But what we were doing is finding the highest common factor. All right. So if we went back, sorry.
I like the language.
So it's up to you which way you want to do it. So if we went now, so now you might be in your book, okay? Find the GCF of, well, what did we do first? 24 and 24 and 54. Let's do those ones. So we're going to find the GCF of 24 and 54. We've done it. All right? So we're going to find the GCF of 24 and 54. Now, we're going to use the prime factors for this. Okay? So yesterday, we found the prime factors by 3 methods, but today we found the prime factors by doing ladder method. Now, when it comes to it, after I've told you to now get on, you are perfectly free to use whichever method you like. Now, what I'm going to ask you is, could you tell me, please, the prime factor decomposition of 24 again? I mean,
Yes.
2 times.
3.
I want the full thing, please.
Oh.
2 times. We had it on the ladder. It's 2 times 2 times 2 times 3 is what I want, please. Right? So 24 is 2 times 2 times 2 times 3. And 54 is what? Okay?
54 is 3.
Could we have it in order? 2 times.
Is that it in order?
You started with 3. You said 3 times 2 times 3 times 3. Not different, it's not in order. The reason, but this is why you said starting with 3 is better. It is, but what we want to do then is to find the GCF. We want to know which factors are common. So you remember we went with if there's a 2 in that one and a 2 in that one, that's one of them. There aren't any other 2s, so we can forget those ones. But there is a 3 in this one, and then that's it. So we forget those ones. Right? And we write out that the GCF then, right, the GCF is 2 times 3, which equals 6. Okay? So that's how we found it. So just to keep it consistent, these are the 2 that I identified. You don't multiply with 4 together. So you now have 2 methods for doing GCF. Right? Print out a worksheet for you. I'm now recording. So anything gets said on my video.
Wait, are we having to work together?
Oh, I don't mind you working to helping the other.
Never mind. Okay. Don't get Kevin. What's the question? Yeah, 3 goes to 2, 1 and he's 7. Why? We have 10 first. Yeah, we're there. And we don't still between them. I think the comment, guys, we're gonna fly the game. Never mind.
This is the sheet, so I can take it off and put the notes back on. Now, for any of you that are thinking I'm brilliant at this, you can actually go on to the harder questions.
It's the ball.
Yes, Kevin.
Does the GCF have to be